Now we have the three things. We have sulfur, we have iron powder. What was the property of iron powder? That a magnet attracts iron powder. If we take iron powder, it gets attracted to the magnet. Now what was the property of this sulfur? That sulfur dissolves in carbon disulfide. Sulfur dissolves in carbon disulfide. Now what we have formed? We have formed a new compound by heating iron and sulfur together. From the mixture we could separate its components because it was a temporary change. By physical methods it could be separated. By iron, by the magnet I separated the iron and the sulfur was left. So it was a temporary change. The change could be reversed by physical methods and no net energy was taken. I did not heat the substance or anything. So this was a physical change. As long as it was a mixture, it was a physical change. When I heated the mixture, then this iron and sulfur, they together formed a compound called iron sulphide. And the iron sulphide is a totally new compound in which all the properties of iron and sulfur is lost. So what were the properties of iron and sulfur? We just now saw that iron gets attracted to magnet and sulfur is soluble in carbon disulfide. Now see these, if we take the iron, the magnet, and it's not getting, the iron sulphide that is formed is not getting attracted to. So iron has lost its property of getting attracted to the magnet in iron sulphide. If I dissolve this in carbon disulfide, it does not get dissolved. That means the sulfur has also lost its identity in iron sulphide. So a new compound is formed where now let's see, the chemical composition of the matter has changed and new compound is formed with new properties. This iron, it has lost its old properties, iron and sulfur. Change is permanent. You cannot get back the iron and sulfur from this compound. It cannot be reversed. You cannot reverse the procedure, means they cannot reverse FeS into Fe and S. Heat is involved, it's an endothermic reaction, although later on it becomes exothermic, but initially you need to heat the compound, so they heat the mixture to get the compound. And there is change of, there's a change of mass. If you weigh both, then you find that there is a difference. There may be a difference. This is not a very, this may or may not be the last point. So these are some of the physical and chemical changes. Now there are some indications of a chemical change. When there is a chemical change taking place, then there are some indications. Indications like what? Like change in color. Suppose I take some copper carbonate and heat. You will see that the color of copper carbonate changes. So change of color is one of the indications of a chemical change. Then next is energy change. It means either it is heat is lost or heat is absorbed. In this, suppose when I am heating copper carbonate, this heat is absorbed. In order to change copper carbonate, you will see that it's changing to black. You can see that it is changing to black. The reaction is copper carbonate converts into copper oxide and carbon dioxide. There is a gas evolved also. If I pass that gas through lime water, it would turn milky. That means what? The gas evolved is carbon dioxide. So the reaction here, you have seen that it is turning to black. The copper carbonate is turning to black. So the reaction over here is these are what we are doing just now are the indications of a chemical change. I mean these things usually occur when there is a chemical change. So CuCO3 on heating absorption of heat is taking place, changing into, this is green in color, as you saw it was green in color, changing into copper oxide, which is black in color, plus carbon dioxide. This can be tested by passing through lime water. So this is one of the changes. The next is evolution of gas. Usually, second is effervescence will take place or a gas will be evolved. So gas formation, evolution of gas. Let us take, suppose I am taking some carbonate over here and I add HCl to it. So evolution of, you can see the effervescence taking, the bubbling occurring, that means a gas is being evolved, and the gas, this is another indication of a chemical change. So I have taken a carbonate, sodium carbonate, and added HCl to it. Effervescence took place with, it's a carbonate, so carbon dioxide is evolved. Carbon dioxide is evolved. So color, gas, third is precipitate. Precipitate may be formed in a chemical change. For example, let us take one, let's take some sodium, so this is sodium, sodium chloride. Let's take some sodium chloride, but it has to be in the solution form, so I'll add some water to it, make a solution, and to the sodium chloride, to the clear solution, if I add, suppose, silver nitrate. If I add silver nitrate, you get a thick white precipitate. So precipitate is another characteristics of a chemical change. Precipitate is another characteristic feature of precipitate. I took sodium chloride and added to it silver nitrate. Silver nitrate, and I got a white precipitate of silver chloride, and of course sodium nitrate, which is soluble in the solution. So this was the white precipitate form. So precipitate formation is another characteristics of a chemical reaction. Energy changes, the state of matter also might change. For example, suppose nitrogen and hydrogen is combining. Nitrogen and hydrogen is state of matter. Fourth is state. Or hydrogen and oxygen, they combine to give water. Both are gases. These are both gases, but this is a liquid. So the state of matter is changing. The state of matter is changing. Two gases like ammonia and HCl, they are combining to form NH4Cl. Ammonia is gaseous, HCl is also gaseous, but NH4Cl is a solid. So the state of matter may also change. So what are the characteristics that we see? Color might change, a gas may be evolved, precipitate may be formed, the state of matter changes, and energy, usually energy is absorbed or energy is given out. Here we can see that energy is absorbed. Example where energy is given out, suppose you take some calcium oxide and dissolve it in water. You take some calcium oxide, fifth point is energy. I have taken some calcium oxide plus H2O. What will be formed? Calcium hydroxide. Plus a lot of heat energy will be evolved, plus heat. That means you will see that it starts boiling, the solution starts boiling. So this type of reaction where the heat is evolved is called exothermic reaction, and this type of reaction where the heat is absorbed, the reaction takes place on heating, that is called endothermic reaction.